Peptide reconstitution is one of the most confusing topics for beginners. In this video, I'll explain how it works and how to calculate concentrations easily. If you've ever looked at a peptide vial and wondered how much bacteriostatic water to add or how to calculate the actual concentration, you're definitely not alone. In this video, we'll break down how peptide reconstitution works, explain the basic math behind it, and show an easy way to calculate concentrations. Most research peptides are supplied as a lyophilized powder. Lyophilization is a freeze-drying process that removes water from the compound, helping preserve stability during storage and shipping. Before the peptide can be used in a laboratory setting, it must first be reconstituted, meaning the powder is dissolved into a liquid solution. This liquid is typically bacteriostatic water, which contains a small amount of preservative to help prevent bacterial growth. Once the powder is dissolved, the peptide becomes a measurable liquid solution with a specific concentration. The key concept behind peptide reconstitution is concentration. Concentration simply describes how much peptide is present within a given amount of liquid. For example, if a vial contains 5 milligrams of peptide and you add 2 milliliters of bacteriostatic water, the peptide is now distributed throughout that liquid. This creates a solution where the peptide is evenly mixed, allowing researchers to measure specific amounts from the vial. The challenge for many beginners is understanding how that concentration translates into measurable units. The math behind peptide reconstitution is actually fairly simple. At its core, the calculation is based on this relationship: amount of peptide in the vial divided by amount of liquid added determines the final concentration of the solution. However, things become confusing because peptides are often measured in milligrams, while syringe markings and dosing discussions are frequently described in micrograms. Converting between these units and calculating the correct syringe measurement is where many people start to get lost. Because this math can get confusing, many researchers use calculators to simplify the process. To make things easier, I built a free peptide reconstitution calculator that walks through the math step by step. You simply enter the amount of peptide in the vial, the amount of bacteriostatic water used for reconstitution, and the desired measurement. The calculator then automatically determines the resulting concentration and syringe measurements. If you want to try it, I've linked it in the description below. It's also important to remember that many peptides discussed online are research compounds and are still being studied in laboratory settings. Information shared online is often educational and research-focused, and it's important for individuals to conduct their own research and consult qualified professionals when appropriate. This video is intended to explain the scientific concept of peptide reconstitution, not provide medical advice. If you want a deeper breakdown of peptide reconstitution, including examples and reference charts, I've also put together a full guide on my blog. You can find both the calculator and the guide linked in the description below. Make sure to subscribe to follow along for what comes next. Thanks for watching.